In this video, I'm going to be teaching you dimensional analysis. Now, dimensional analysis is when units are multiplied together, divided into each other, or cancelled. Using dimensional analysis helps ensure that solutions to problems yield the proper units. It also provides a systematic way of solving many numerical problems and of checking solutions for possible errors. Now, let's start with a simple problem. Let's say a woman has a mass of 115 pounds. What is her mass in grams? First off, we want to start with the number we are given. Now, to get from pounds to grams, we need a conversion factor. That conversion factor is 453.6 grams per 1 pound. Now, to do this, you want pounds to be underneath the pounds we already have. So, $453.6 grams equals 1 pound. Alright, so you have 115 pounds up here, and now you want this 1 pound on the bottom so that the units cancel out. Next, you put 453.6 grams on the top. And that is your equation. Pounds cancels out, and you're left with grams up here. Now all that's left to do is multiply. 115 times 453.6, which gives you 52,164. Though if you're using sig figs, you have 3 sig figs up here, so it would be 52,200 grams. And don't forget your units. No naked numbers. That's what my teacher always says. Now let's move on to a more difficult problem. The average speed of a nitrogen molecule in air at 25 degrees C is 515 meters per second. Convert this speed to miles per hour. First of all, start with what you're given, which would be 515 meters. And since it's per second, it's 515 meters over 1 second. So we would do over 1 second. Now for this next step, we need to ignore one of the units in order to solve for the other one. So for this, let's go ahead and ignore the 1 second and just pay attention to 515 meters and try and convert that meters into miles. Now, there's 10 to the third meters per 1 kilometer. So that cancels out the meters. Now you want to follow kilometers to miles. And there is 1.6093 kilometers per 1 mile. Kilometers cancels out. So now you have the miles that you're looking for on top of the equation. So now you can ignore miles and focus on converting seconds to hours. Okay, to convert seconds to hours, first you want to go to minutes. There are 60 seconds in 1 minute. Cancel out the seconds. And then in 60 minutes, there is 1 hour. Minutes cancels out. An hour ends up on the bottom of the equation, just like it is here. So then that's your equation, and then you multiply it out. 515 times 60 times 60 divided by, and then make sure to put all of this bottom part in parentheses. 10 to the third times 1.6093. And the answer you're given is 1,152 miles per hour. And if you're going for sig figs, it would be 1.15 times 10 to the third miles per hour. Next we will try conversions involving density. In this problem, we are being asked, what is the mass in grams of 1.00 gallons of water? We are also given the density of water, which is 1.00 grams per milliliter. First, you would start off with the 1.00 gallons of water. Next, you would use the conversion factor 1 gallon per 4 quarts. So to cancel out units, you would put 1 gallon on the bottom and 4 quarts on the top. Gallons cancel. Now you use the conversion of quarts to liters. There is 1.057 quarts per 1 liter. In 1 liter, there is 1,000 milliliters. Let's cancel these units. We currently have milliliters at the top of our equation, and we want to get to grams. So here is where we would use the density of water, 1.00 grams per milliliter. Since it's per milliliter, that means milliliter is on the bottom. It's below this division sign. So we would put 1 milliliter below the division sign and 1.00 grams above. Milliliters cancels. So now all that you're left with is grams. Now it's time to multiply it out. You have 4 and 1,000. 4 times 1,000, because multiplying it by 1 wouldn't do anything. Then down here you have 1.057. So divided by 1.057. That gives you this big long number, 3,784 yeah. You have 3 sig figs, so you would do 3.78 times 10 to the third grams. Next, we will be converting grams to moles. Say you have 5.380 grams of C6H12O6. How many moles are there? First of all, of course, always start with what you're given. 5.380 grams. C6H12O6. Now you know how you have grams up here, so you have grams down here to cancel out, and moles up here. First you need to figure out how many grams of C6H12O6 are in 1 mole. To do that, you would look at their atomic mass units on the periodic table. C carbon has 12. And since you have a 6 right here, you have 6 carbons. So you would times the 12 by 6. H has 1 atomic mass unit, but you have 12 H atoms, so you would multiply that by 12. Oxygen is 16 atomic mass units, and since you have 6 oxygen atoms, you would times this by 6. Now multiply to get your answers. 72, 12, and 96. Now you add all of these weights up. 72 plus 12 plus 96, which gives you 180 grams. So you would put 180 grams per 1 mole. And that's all you do. 5.38 divided by 180. And that gives you this big long number right here. 0.029888889, blah blah blah. Here you're given 4 significant figures, so you would do 2.989 times 10 to the negative 12 second moles. And that's your answer. Now we will be calculating numbers of molecules and atoms from mass. The question says, how many glucose molecules are in 5.23 grams of C6H12O6? So let's write down our problem. 5.23 grams of C6H12O6. And how many molecules are in there? First of all, start off with what you're given. 5.23 grams of C6H12O6. Then you figure out how many grams are in a mole, which we just did that in the previous problem. So it's 180 grams over 1 mole. And for 1 mole, there is 6.02 times 10 to the 23rd molecules. Units cancel. .23 times 6.02 times 10 to the 23rd divided by 180. We have 3 sig figs, so our answer would be 1.75 times 10 to the 22nd molecules of C6H12O6. And that's it. Now let's get a tiny bit more complicated. The second part of this problem asks how many oxygen atoms are in this sample. So first of all, you would take our answer from the previous problem, 1.75 times 10 to the 22nd molecules of C6H12O6. Now, you see there's no coefficient in front of this whole compound, correct? So there's 1 molecule of this compound. So follow in your units so you can cancel out. There is 1 molecule of C6H12O6. But if you look here on the end, what we're looking for is atoms of oxygen. There's a 6 at the end of this problem where the oxygen is. So that means there's 6 atoms for every molecule of glucose. So up here you would put 6 atoms of oxygen. And that's it. 1.75 times 10 to the 22nd times 6. And there's your answer. 1.05 times 10 to the 23rd atoms of oxygen.